Hey everybody, thanks for having me here. First thing I want to do is apologize for the title. It's a pun. I looked at like 10 puns, and I was trying to see if one of them could make people laugh. If one would make me laugh, but no pun intended. So we're stuck with this one. I want to start off asking a question. What are generators? It's an easier question to answer than if you were in deep interactions. What is thinking? It's pretty straightforward. Generators are functions that have multiple return points. So you can yield, you can return values to your caller multiple times before your function's finished executing. And in ECMAScript, which is what I'm going to talk about, that implementation, it's even more powerful. So in ECMAScript, it's even more like collaborative functions. And that's because you can sort of pass values back and forth between the caller and the generator as you go. This is all the syntax you need to sort of use generators. There's 3 parts to it, basically. I don't know if you can read the code there, but the first part is generator functions themselves, and you can see there's little function star syntax up there, function star genfunc, and that star just indicates that it's a generator function, not a normal function. And a generator function is basically like a constructor for generators. So no matter how you call it, you get a generator back. And once you have a generator, there's 2 ways you can interact with it as a caller. So there's the next function and the throw function. And then when you're in the generator, there's extra syntax there too. So there's the yield keyword, which we'll use to pause the generator. So just go into detail more. Generator function is it's a special kind of function. It has an extended prototype. So there's generator function prototype, which is subclassing the function. So it's very special. But you can use it like a function, right? It has all the bind and call and apply and everything. And no matter what you do, you get a generator back. So when you're executing, like I said, next and throw. And the way those work is you can pass a value in. So you call next with a value, and a value goes in. And what you get out is a special object. So this object is always an object with 2 properties. It has value and done. And so value is the value that comes out of the generator, and done is whether the generator can be executed again, whether it's finished executing or not. So here's how you use it. You call next, you pass in a value. It evaluates to what the generator is giving back to you. That object that has the value and the done that the generator is giving back to you. You check done. If it's not done, then you can use the value. So it's pretty straightforward. Throw is exactly the same with one condition, which is instead of passing a value into the generator, it throws an exception in the generator. And Brendan Ike, that quote at the top is from Brendan Ike in ES Discuss. And he also used that little image quote too. Doctor, it hurts when I do this, then don't do that. So in the generator, you use yield to pause. This is basically all the syntax you need inside of a generator. So the yield is the pause point. So you hear the first time you call gen.next, this particular function will yield a 1. So gen.next, the value in it will be 1. And the next time you call gen.next, you can pass in a value. And this particular function will take that value and put it in A. So that's generally how yield works. That's the communication point between the caller and the generator. And those are the points where the generator anything can happen, right? The generator gets paused there for any amount of time, and then you come back to it. There's also yield star, which is sort of like the sister to yield, but it's more of a forwarding mechanism for that one. So you pass it another generator, and essentially that generator gets control of how you're executing now. So rather than you controlling what values get passed to the caller and looking at the values that come from the caller, all that happens in the second generator until it finishes executing. And return, I wanted to point out that return has a very special meaning here. It's kind of like a foot gun in generators. So when you return something, it's not the last yield. Like you don't want to yield a bunch of things and then the last thing you yield, instead of yielding, you return. That's not going to work. It has a special meaning for things like yield star. So where yield evaluates to something that came from the caller, right? So var A is being set to something from the caller. Yield star evaluates to something from that that B generator there, that genfunc B. So whatever he returns is what you get from yield star. And there's a whole bunch of other caveats. So return is a very special case and has a very special purpose. Here's an example of using a generator. So this is a tree traversal infix. It's pretty easy to read. This is sort of one of the basic advantages I think you get from using generators, which is everything just sort of reads very nicely. So this traverses a tree. You can see it's recursively calling itself in the first line on the left subtree. So it'll get all the lefts, and then it'll get the center of each one, and so on. And then it calls itself. It yields its own value, and then it forwards from the right subtree. The bottom part of that is some kind of nasty code, but it's calling that tree traversal generator. So you can see we're checking. I'm using the comma operator there in that while condition, which is kind of rare, and people don't like the comma operator, but this is like the right place to use it, I think, in my opinion. So we call next, and we put that in our next variable, and then we check not next.done. And so the while condition evaluates to not next.done. So as long as we're not done, we keep going. And in this case, I'm just console logging the value out of that. So it's pretty straightforward. And that's about it, right? That's all there is to generators. I showed you the syntax. I think you could probably go out, play with it a bit, and know what you're doing pretty quickly. But there's definitely something hidden in generators, and I'm really excited about what we can do with them. So at the beginning of this talk, I called them collaborative functions. And I think that's really where the power is. So generators, about half of their power comes from not what's in them, but what you call them with. So let's go to like the basic sort of standard canonical use case for a generator in any language, which is lazily evaluating things. So here we have an infinite sort of collection of numbers, right? We hope. We're looping over while true, and we're pushing these numbers onto an array, and we expect to return that array of infinite numbers. But that's just not going to happen. So what you can do instead is you can use a generator. And a generator will sort of yield one value at a time and iterate each time, right? So this is an infinite sequence, right? This is all the numbers from 0 up, which is kind of cool. It's not often you get to represent something like so pure like that. And you can iterate over it specially. So I think Axel touched on this in his talk barely, but there's a for of syntax. And that's specifically for iterating over generators and things like that. So in this case, we have all the numbers, right, 0 and up, and each one will go into the n. Now this would be an infinite loop, but we're doing a manual break there to avoid that, so that's good. And I got the desugaring at the bottom, but I'm not really going to go into that. And you can do cool things. There's higher order generators, right? So there's skip and take, for example. So we can take our infinite list of numbers, right, 0 to infinity, and we'll skip the first 10. So now we have 10 to infinity. And then take the next 10. So now we have 10 to 19. And you can do basic paging with this. I think it's pretty straightforward to read. It makes things nice and clean, in my opinion. .NET and Link in C# have had this sort of concept for a while. And they've built on it with IEnumerable. And you can do that in JavaScript now. I think Aaron Powell, who's here, wrote a blog post about it. And there's functions like where, right? So we can take our infinite list of numbers, and we can make it an infinite list of prime numbers by filtering out all the other ones. And we can take that and then multiply by 2. And now it's an infinite list of doubles of primes. And then we can take the first 100. It's just really nice and clean. But there's completely different use cases for generators, too. And this is the one that has gotten a lot of attention recently. You have a pyramid of doom like this, right? The callback hell that you get into. So you request data from the server. Maybe, in this case, you want to display a form, and then the user submits the form, so you post it to the server, and then you get a result. And any one of those can have errors, and it just gets kind of messy. So what people have shown online a lot and use this for is making it look synchronous. So here we take, instead of using a callback, we yield the result of each function, and there's something coming out of that. And magically, on the other side of the yield, we get the actual result that we expect in the callback. So it's really pretty. And you'll notice that it's wrapped in async, right? So the cool thing here is, like I said, half the power is in how you call it. Async is doing some magic behind the scenes. And as long as you know sort of both of those, how both of those work together, you're golden. There's also try catch here. So if there's any errors, async will throw them back into you using gen.throw, and then you can handle them synchronously like they were synchronous errors. So I'm really a fan of this. I think there'll be a lot of nice readable code out of this. Make things nice. I just want to go into how that works a little bit. So if you don't know what promises are, they're basically something like this. Rather than using a callback, you return something. And that's sort of how this is powered under the hood. The promise lets you attach callbacks to your function, and they'll get called when it's, when it's finished. So it would look kind of like this. You get kind of halfway there. You call then on each of the promises, and you just stack them up, right? Request data, then display form, then submit form, then display result or display error. And that's actually what's happening behind the scenes, right? So that's the magic that's in async. It just calls then for you, and in its then callback, it calls the generator again with the result. And so that's how you get the synchronous sort of look. But there's really like lots of things you can do with generators, right? These are just the two that people have sort of focused on, and they are pretty cool. You can do things like auto batching, right? So there's this online code editor called CodeMirror, and it's used in like Chrome DevTools and things. And the way they do syntax highlighting is they basically batch things up. So they spend some time doing syntax highlighting and some time letting the UI re-render, right? Because if they didn't do that, the UI would lock up, and that would be pretty ugly. But there's a lot of code there that you don't really want to see in your highlighting code, right? It doesn't really make sense. So this is one case where generators could be cool, right? You stick it in a throttled method, it handles the batching, it only calls you after a set timeout, if you've been working too long. You get a nice little encapsulation there. David Nolan did ClojureScript, has talked about Go-style coroutines. So this is sort of, this is Go language style coroutines, and the way it works is they have channels, right? And these channels are sort of queues where two different threads of execution can kind of collaborate on something. In his example, you have one that's putting things onto the queue, so it puts 0 to 9 up on the queue there, and another one that just takes things off. And the cool thing about this is it's a really nice, efficient way to sort of get pipelines going, right? So you can have this one put one on, and the next one takes it off, and they just execute lockstep, right? So you get, put one on, take one off, put one on, take one off, and you get a full pipeline going. So that's pretty cool too. There's also like dumb things you can do. Somebody implemented Haskell point-free notation with, or sort of a mock point-free notation with this. And what that means is like in Haskell, people like to represent functions without talking about the arguments. So rather than saying, math.log of x equals y, or y equals math.log of x, and then saying, math.min of y and 2, you just sort of mention the functions. So you say math.log math.min 2 or whatever. You never mention the y or the x. You can generate infinite trees, so like decision trees. You can collaborate with your caller on this, right? Each time the caller can make a decision, and then you generate the subtree for them to continue on with their decision process. So there's all sorts of cool, weird things and concepts that you can do with generators that you don't really think of otherwise. I gotta say, I'm pretty excited about this. I think there's a lot of cool potential there. And you can already start using it. So this is in Chrome. There's a flag for it. It's enable JavaScript harmony. It's in Node unstable right now. That's the version 11 under the Harmony generators flag, or you can just use Harmony if you want all of it. And it's in Firefox, and there's no flags or anything. In Firefox nightly, sorry. And that's it. That's all.